Okay, so I want to draw the tripeptide with these three, the aniline, the tryptophan, and the threonine. So I'm going to start off with the aniline, and we're going to have a H3 plus NCHCH. NCH3. All right, so aniline is here, and I'm missing the OH group because what's going to come next? What's going to be connected right here? So what was removed? Yep. Nothing there. Nothing down there. Okay. Are we good with that structure? So this is the start of what kind of structure? Which structure type?
Primary.
Primary, just the actual sequence, but no secondary folding, no tertiary structure folding. What type of reaction causes these two amino acids to bond to each other? What's the name of the bond? Yeah, it's a dehydration. And peptide. Primary, what's the primary structure for these proteins?
Is that what you said?
Second?
Like the back.
No, I wouldn't consider this the backbone. When we talk about backbone, we're specifically talking about just the carboxylic or the amino acid part, but not the chain, or sorry, not the side chain. These are definitely connected by the backbone, but the R group is attached to this. And the secondary structure? What does this have to do with the backbone? So they make an alpha helical shape and a beta pleated sheet shape by having the so I get the oxygen and the hydrogens to have an intermolecular force with each other in a very regular pattern, either a stair-steppy kind of pattern, which is my beta, or a spiraling staircase, which is my alpha. And it looks very regular because it's the backbone interacting with itself. The backbone interacting with itself, since it's nitrogen, carbon, carbon, nitrogen, carbon, carbon, nitrogen, carbon, carbon, it's very regular along the sequence. So I'm going to get something that looks very regular. So a bunch of stairs or a nice alpha helical. So anytime I'm looking at a secondary structure, I'm looking at something that's going to be a regular repeating pattern. Okay. Wonder why I don't have the other two on here. Odd. How does an amino acid act like a buffer? So in this case, I can, how do I change pens? If I added a hydrogen to this mix, it would just attach itself there and then it would be removed. And if I added a hydroxide to this, one of these H's would come off and then this thing would form a water molecule. So it manages both acids and base increases. What is it that we did to manage to separate out the amino acids? Yeah, okay. So pick a pH for the solution. And then so pick a pH for the solution. I apply an electric field. The pH, which is going to be called the isoelectric point, the PI. If I pick the PI for a particular amino acid, that amino acid will be neutral. So when I apply the electric field, what's going to happen? Everything else will move. It's going to stay there because it doesn't have an overall charge. So basically, I'm just isolating that one thing by pulling everything else out of the mix by picking a particular pH. Okay.